We're all computer science majors. Today we'll be presenting our project, Detecting Birds with Real-Time Image Processing. So real quick, we're going to go over this outline. First, we're going to go over our background, then our system diagram, our roles on the project and our progress, some challenges that we faced, our future plans, a quick demo, and then we'll open up the Q&A. So our objective is to develop a real-time bird detection system for drones to prevent them from colliding with the birds. So some background real quick. You may have come to realize that drones have kind of come into more prominence recently. If you've heard about Amazon planning to use drones for delivery, all sorts of things. However, drones not only pose a pretty large threat to birds and ecological hazard, but the birds themselves are pretty hazardous to the drones. And that can cause them to fall out of the sky, stop deliveries, all sorts of things. So how are we going to avoid bird and drone interaction? Well, our approach
is to use machine learning to detect birds through through video that a drone records, and we're going to establish a two-way communication system between a computer and the drone so that the computer can process the images that the drone records. And we're also going to develop a UI control system so that we can easily change and modify parameters with the actual image processing and the video stream. So there have been similar projects before with vehicles that aren't drones and larger vehicles, and there's also been similar projects and research with image processing for drones, or for birds. And we hope to take this image processing with the birds and put it on the drones, as that isn't something we have really seen before.
So just some explanation on how this actually works. We are using a process called object detection, which is basically when you train computers to detect objects and images by first providing them with a large amount of labeled images until they get good enough at recognizing patterns where they can look at an image that isn't labeled and identify them. For this project, we are specifically giving our model labeled images to detect birds. The model is going to draw a box around anything in the frame of the video that it thinks is a bird with an accuracy percentage to how confident it is that it is a bird and not something else. So for the project rules, I am primarily focusing on the machine learning and algorithms of this project.
I'm doing the front end and user interface.
And I'm doing the physical implementation and the communication. So here's a diagram showing just a general outline of how our system is working. So we have our drone, which is going to be looking out with a video feed. It has a camera on the front, and we'll show you in a second. And it's going to be looking for birds. And then it's going to be sending this video feed to a phone, which acts as like a controller for the drone. And then this phone is going to send that video feed to a computer, and this computer is going to do all of the image processing that we need. And then we can do all of that backwards to send instructions back to the drone. So for our materials, first off, here's the drone. It's the DJI Mavic Pro 2. You can see this little camera on the front, and we don't have the propellers on it, but it's a good visual for what we're dealing with here. On the phone, we have an app called Rosetta Drone 2 because the drone uses DJI's API, which basically means it's kind of hard to access the drone directly from a computer. And this app is like a bridge between DJI's API and a protocol called Mavlink, which is how we send instructions back to the drone. And then we use a Python library called DroneKit, and that allows us to send instructions directly from the code that we're already doing our image processing.
So all the processing is being done in Python. For the actual object detection, we're using a very powerful library called TensorFlow, developed by Google, which has numerous machine learning operations, but for this project, we're just using object detection. And to actually prepare the videos so we can do object detection on them, we're using a library called OpenCV2.
For the user interface, I use a software called PyVuvu, and then I'm also going to be using the Python library tkinter. This is our progress so far. This semester, we completed everything that we had set out on our schedule.
So for the machine learning progress, we have successfully trained the model to detect birds with adequate speed and accuracy. Currently, it's interfaced to work with videos or live streams, but moving into next semester, we plan on connecting it directly to the feed from the drone, so we can take the video from the drone and then send commands back.
For the current progress for the user interface, I have it in 3 columns. The first one has the stream recording and console log functions. The second one has the stream and the console log. And the third one has the options for the stream, the AI model, and video settings. And now you can actually see what it looks like. You can see it has like on the right the buttons that you need to do to control the stream, and the stream with the detection boxes and options such as the color of detection boxes or distortions applied to the video.
So for the drone communication, we've actually processed a video that we recorded on our drone, and we'll show you that later. We've researched two-way communications using DJI's Drone SDK. We began work on Python compatibility so we can send instructions to the drone straight from our code. We've also researched hardware components for future plans to do all of the image processing on the drone itself.
So, we've had some challenges this semester, but we are working to overcome them and expect to not have to deal with them in next semester. For the machine learning, we have noticed that in large flocks of birds, there's a decrease in both accuracy and speed. One way that we hope to get around this is when we have a large amount of birds, rather than classifying them one by one, we're going to classify them as a collective, a flock of birds. Another issue we're facing is false positives, which is when the model detects something as a bird when it isn't a bird, like a tree branch, person, something that kind of looks like a bird. We plan to fix this by retraining our model with negative images, meaning images that don't have any birds in them, so the model is more accustomed to the idea that there isn't always going to be a bird in any given video.
One of the challenges in creating the UI was selecting a framework to use for developing it until I settled on Python.
For the communications, we originally established a one-way communication, so we just got a stream straight from the drone, and that was fairly easy to do. But to actually act, like if the drone sees a bird, we have to be able to send instructions back. So that's why we needed a two-way communication system, and this is much more complicated.
So for our next semester's plan, we want a way to approximate the distance from the drone to the bird using the video feed. We don't need to know the exact distance, we primarily just need to know if the bird is close enough to the drone where a problem is going to arise. Next, we want to connect our detection system to our image processing system. This will be fairly straightforward since they're both made in Python. And then we can also connect it to the control system using a commercially available API to connect to that drone. The reason we're doing this is that it would be easier to reproduce if anyone else wanted to just download the code for a project and put it on such a drone.
And then for our stretch goal, in the future, and next semester, we actually want to have all of the image processing done on the drone itself, so no communications to a computer. The drone can just see a bird and act completely on its own accord. And we've already done research on the hardware components that will go into this, but this is pretty far into the future. So we need to make sure we can get this two-way communication system done before we can even start on this.
All right, so we are now going to show a short demo. This is an isolated demo just showing the machine learning detection system on a few test videos. The first half is going to show an ideal conditions where there are very large birds on a static background. The second half is going to show something more realistic where the birds are small, they're moving, there's trees, so you'll kind of see how there's some differences and how we have some things we need to work on next. So starting the video. One second.
Oh, I hate it when it does that.
Oh, we're not connected to the internet.
Oh. That happens with my computer. It's okay. I don't think it can fix that. What? Technical errors.
1 second.
Although it's ironic because the computer science students having trouble with the computer.
Yeah, this we do, but this video.
Must be, is it on YouTube? Is that why it's making them connect?
Probably.
Yeah. It's probably on their YouTube.
Yeah, it looks like it's better YouTube.
No, I don't know. That's what you're saying. Oh, there it is. There we go.
Yeah, no, this is your sister.
Oh my gosh.
No.
Exactly.
It's okay. You're doing great.
Oh, here we are.
Okay.
There we go. Okay, we're good. We're good. All right.
Oh, thank God.
Okay, thank you for bearing with us. Okay. Now,
We gave everybody a chance to take some bites.
so let's maximize this room. Or I guess we can't. So, as you can see, we have this video of seagulls. So these are a good example to start with because they're very large and they're pretty close to the camera. It is able to predict them pretty accurately. You can see it's tracking them fairly well, but you'll notice when there's a lot of birds on the screen, it kind of slows down a bit. You can see that with the frames per second count. It begins to lag a bit. So that's an issue we want to solve moving to next semester. In a few seconds, we're going to switch over to this demo. So this one shows a flock of birds far away. As you can see, it kind of freezes up to process them all. And then you also notice that there's some flickering in the bottom where the trees are. That's a false positive that we need to address. However, it is able to predict these fairly quickly. It's on average 30 frames per second, which is the target we were aiming for this semester. All right.
Thank you all for your time. Do any of you have any questions?
Any questions for them?
How robust is the machine learning algorithm to different lighting conditions?
Can you repeat that last part?
How robust is the machine learning algorithm that does the image processing for different lighting conditions?
For different lighting conditions. Let's see. We haven't done extensive testing on it, but the conditions definitely slow it down. And you can see in the video when we had the kind of better lit time, it was a lot faster. However, when they were further away or other conditions, it does kind of lag a bit. This can easily be addressed. When we're training the model, there's options to put effects to the images, like darkening them. So we just need to extensively retrain the model with different lighting conditions, and this will be addressed.
And we have options in our UI to where we can press buttons and have that happen automatically.
Yes, we are planning to have like video editing options, so we can just make the frame higher contrast or higher brightness if that would solve it.
If it's not a bird, I don't know, I cannot think of anything but like a balloon or like something else, but it can it tell if it's not a bird?
Currently, no. Moving to next semester, this is something I'm going to address. Right now, the detection system is only set up with one class. We've been talking to include more than one class, so we'll include some common things that aren't birds, so that can detect them and, I guess, react differently or not react at all.